Hi all. Let's do some more C++. We're going to do number 5 today. You can see in here there's 10 programs. They're real short. And they're all kind of the same. So we should be able to get through them in one video. And then we have a lab 2. I'll put this folder on C:. That's just a shortcut to a CPP folder on C:. So I'll drag this in here. And I'll start up the DOS prompt. Let me change the colors here. We'll make the font just a little bigger and bold. And colors, background is white, and text is black. That should make it a little easier to see. And then we'll navigate to this folder. So CD. That's just a fancy way to move back 2 folders. User 01 is a folder and users is a folder. So that brings us back to C:. Now we need to go into the CPP folder. So we go CD into the CPP folder. Now we need to go into the 05 folder. CD 005. Now we're into the 05 folder, and inside here we have these 10 programs. Okay, so first we go into the number 1, CD 01. So that brings us into here. Then we'll run the compiler BCC32. And we'll compile the file. No errors, so it worked. And we'll run the program, and it prints out a number 1. So let's look at the code. So this is the first one we've done with numbers. You see it still starts with main function. But now we're creating a number. A fancy word for a number is just an integer. And we're giving it a name. We're giving it a name of A. You can name it anything you want. So, and then we're putting a 1 inside A. And then we're doing a cout. And we're outputting the value of A to the screen. So that's how we got a number 1 here. Okay, so we have our header, iostream.h. That just enables us to use cout. We don't have to add 1,000 lines of code to output something to the screen, to the DOS prompt. It's included for us here. So we're using that file in order to grab cout. Cout is in this file here. Then we have our main function. All C++ programs start at main. So right now we only have one function. Our one function is main function. Void main void is kind of like an old style of header, but I wanted to start with that. Void just means we're sending nothing back to the operating system. Sometimes, like if you have an error message, you could put int here, same as the integer here, and when you get an error, it sends that error number back to the operating system. But for the most part, we don't have to worry about that for a while. And this just means we're not sending anything in to this function. When we get into having more functions, 2, 3 functions, then we'll start putting things here. And void just means nothing. Okay, so the important part is here. We're creating an integer and we're naming it A. So now we have like a storage area to stick a number in. Okay, our storage area is A. And we're sticking a number 1 inside here. Okay, and then we just take A and output it to the screen. Okay, so if we wanted to, we could change that to 2. Save the file. Run the compiler again. Run the program again. And now it outputs a 2. So now we have 2 stored inside A. Okay, so integer. Now we'll do 2. So we got to back up a folder. Now we'll go into O2. We'll compile it. Okay, so it worked. And then we can run it. And we get 3.3. So this is the same type of thing, but we're doing it with floats. Float is just a fancy word for floating point numbers, like if you have a decimal point. So we create 3 floating points, A, B, and C. Then we store 1.1 in here, 2.2 in here, 0, 0 in here. Here we're just clearing out the memory. There's garbage in the memory, in your RAM. So that's just like a good thing to do, so you know that area of RAM is cleared. And then we're adding the 2. We're going A plus B. So that's A and B. So 1.1 plus 2.2 is 3.3. 3.3 is stored in here. And then we output 3.3 to the screen. And that's how we get 3.3. Here, we're getting an error message here, or a warning. See, there's a difference between errors and warnings. This is just a warning. It's saying C is assigned a value that is never used. That's that guy here. Saying you're assigning it 0, 0, but you're never using it. So just, if we wanted to mess around with this, you could say I'll put C here. So now that error went away because we're using C here. So now if we run it, now we get 0. And we get the 3.3 here. That's kind of odd. It didn't print 0.0 here. Okay. Okay, now we'll do 3. Back up a folder. CD into 3. We'll compile it. Same thing here. And then we'll run it. So 3, we're working with doubles. So 3, we're working with doubles. Double is just a fancy word for big decimal points. Stuff like this. So we create 3 doubles. Store this guy in A. Store this guy in B. Clear the memory here. Add A and B. Store it in C. And then we output C here. That's how we get this number here. And you can see because it's a big decimal point, it throws it into a scientific notation. I wouldn't worry about that for now. If you're into math and science, you understand what's going on there. But so right now, it's really not that important. So. And then 4. We're just adding up integers. You make 1 integer here, make 2 integer here, make 3 integer here, A, B, and C. Put 1, put 2, put 3. We add them together, store it in C, and then we output C to the screen, and that's how we get the 3 here. Five is the same thing, but this is how you do subtraction. So create 3 integers, store 5 in A, store 2 in B, store 0 in C, and then we go 5 minus 2, store 3 in here, print out C, that's how we get the 3. So these should be pretty easy. Run the compiler, run the program. So this is how we multiply. Same thing up top here, A, B, C, 3 and 2, 3 times 2, put 6 in here. output C, that's how we get the 6. Okay, so this is how you divide. There's no symbol on the keyboard for division that you would normally use on a piece of paper. So they use the / for the division sign. So create 3 integers, store some numbers, then we go 10 divided by 2, store 5 in here, output C to the screen, and that's how we get a 5 here. Eight. Run the compiler, output the program, got 5. So this is a square root. Okay, we create an integer A and put 25 into it. See how we're doing it all on one line now? In the other videos or in the other programs previous, we did it like this. Create integer A and then store 25 in it. If you want, you can do it all on one line. It's a personal preference. There's no right or wrong. I prefer to do it like this. It seems to be easier to keep track of, but there's nothing wrong with this. This is a more modern style here when you do it all on one line. And then we create an integer B, and you can see we didn't clear the memory. If we wanted to, we could do something like this. And then we use the square root function. Just like this was the main function, this is the square root function. It's a built-in function that does what it's going to do behind the scenes. And all we have to do is know how to use it. What do we send it? So we're sending it A. So we're taking A, sending A to the square root function. It gets the square root of A and stores the total in here. It has a return value. The square root function returns a value. It returns the value and stores it in B. And then we output the value of B. That's how we get the 5. Okay, so call the built-in square root function. That's this. We call the built-in square root function and send it the value. The value is a. We're sending it 25 of a to get the square root of a of 25. The square root function returns a value of a and stores it in B. Okay? So this is something that's kind of tricky right now. We're just using a built-in function to do our math. If we wanted to, we could have done it the long way, but it's nice to use these built-in functions. I just like to show these because there might be some math people out there that say, well, how do I do this? How do I get this into my code? Well, there's all types of things like this that you can use. You don't have to start from scratch and write your own square root function. You can if you want to, but you don't have to. Okay, then 9. We'll compile it. Oh, 9, I have 9 named mod. So let me change that. We'll compile it and then we'll run it. We run it and we get a modulus of 1. Modulus is just a fancy word for the remainder. When you do a division here, so like we're going 21 divided by 10 is 2, and the 1 is left over. So that's the 1. So here we're saying create an integer. We'll name it my mod, instead of saying A, B, C. It's nice to name your variables with some type of meaningful word, because as your programs get bigger, it's hard to keep track of what's going on. And then we cleared the memory. We get the modulus by using the percent sign. So we're saying 21 mod 10. That's like doing this here. And it sticks a 1 inside here, because the 1 is the leftover one. And then it prints out my mod to the screen. And that's how we get a 1 here. That one is kind of weird. This here is really, if you don't understand what's going on, that's not real clear. Don't worry about it if you're not a math person. I'm not going to turn these videos into a math course. Maybe later on, months down the road, we might get into that type of thing, but we've got a long way to go before we get into that type of stuff. So we're just going to go after C++. Okay? And this last one is kind of cool. Okay, let's check it out first. So